Now, as we started, that S block is divided into two parts, that is group 1 and group 2. Now, to understand them clearly, we need to first understand what is the electronic configuration of the elements present in group 1 and group 2. By understanding so, we'll understand why these elements lie in group 1 and group 2 in S block, and let's start with it. Now, if I take group 1, which is also known as alkali metals, and I take group 2, which is known as alkaline earth metals. Alkaline earth metals. Now let us see what are the elements: lithium, sodium, potassium, rubidium, cesium, and francium. These are the elements which are present in group 1, which are lithium, sodium, potassium, rubidium, cesium, and francium. If I write the electronic configuration, it will be the last electron enters of lithium is in 2s1. In sodium, it enters in 3s1. In potassium, it enters in 4s1 orbital. In rubidium, it enters in 5s1 orbital. In cesium, it enters in 6s1 orbital. And in francium, it enters in 7s1 orbital. As we can clearly see, the numbers of electron are 1, 1, 1, and every last electron enters in s orbital. Only the number of shells are changing, but the orbitals are same, as we have written their electronic configuration with the help of noble gases. So we get to know that every electron of s block enters in the s orbital only. That is their last electron. Now, similarly, if I go to group 2, which are known as alkaline earth metals, and write their electronic configuration, which is for beryllium, magnesium, calcium, strontium, barium, and rhodium. So we get to know that they have electronic configuration of helium 2s2, because we know that beryllium has a atomic number of 4 and helium has atomic number of 2. So 2 and 2 electrons present in s orbital, totals add up to 4, hence beryllium atomic number is satisfied. Similarly goes for magnesium 3s2. Similarly goes for calcium, which is argon 4s2. For strontium, it's krypton 5s2. For helium, it is xenon 6s2. And for rhodium, it is 7s2. Now, as we can clearly see, the last electrons in group 2, all the elements last electron enters in s orbital, and they have last two electrons in s orbital. As we can clearly see in group 1, the valence electrons are 1, but in group 2, the valence electron, that is electrons in last orbit, are 2. So this makes a very clear difference of s orbital elements, that elements which have last electron as 1 in s orbital are known as group 1 elements, and similarly the different ones are known as group 2 elements. So that is how we clearly see the difference between group 1 elements and group 2 elements. Now we need to know why group 1 elements are known as alkali metals and why group 2 elements are known as alkaline earth metals. For that, we first need to understand that group 1 elements are known as alkali metal because alkali metals because when they react with water or when they are added in water, they react with water, they form hydroxides. Hydroxides, which are basic in nature. that is basic in nature. What do we mean by this statement is that, let us suppose if I take sodium only and I react it with H2O, I get sodium hydroxide. And this sodium hydroxide compound so formed is basic in nature because all the hydroxides are basic. Hence, it is known as alkali because basic compounds are also known as alkali compounds. Hence, as every element in group 1, that is lithium, sodium, potassium, rubidium, cesium, and francium, when react with water form hydroxide compounds, and hydroxide compounds are all basic. That is why they are known as alkali metals. Similarly, if I study about group 2 elements, this goes the statement for them also, as they are known as as alkaline earth metals. What do we mean by alkaline earth metals? As the alkali word in both the situation is same, but here the word earth added up. This earth addition is because of the fact that group 2 elements are found in earth crust in the form of oxides that is, we don't found them unbonded, they are present as oxides in the earth crust. So hence they are known as alkaline because their reaction with water gave us hydroxides which are basic in nature, and their oxides are also basic in nature. Hence they are alkaline. Earth because they are found in the earth crust, and metals because they loses electrons. Hence they are known as alkaline earth metals.